All right, let's dive in. Today, we're going to get to the bottom of a question that's stumped scientists for centuries. It's a question about the very nature of motion itself. We are going to unlock Newton's first law. So let's get started.
You know, for the longest time, the answer to this seemed, well, obvious, right? If you want to move something, you have to push it. When you stop pushing, it stops moving. So the common wisdom was that the natural state of everything is just rest. But is it really that simple? This one simple question puzzled some of the greatest minds in history until a few key thinkers came along and saw the world in a completely new way.
So here's our game plan for getting to the answer. First, we'll talk about the hero of our story, force. Then we'll get into the difference between balanced and unbalanced forces, a tale of two forces, you could say. That's going to lead us straight to the big reveal, Newton's first law. And finally, we'll bring it all home and see how this stuff pops up in your life, every single day.
Okay, first things first, if we really want to understand motion, we have to start with the thing that gets it all going in the first place. And that cause has a simple, really powerful name, force.
And that's pretty much it. A force is just a push, a pull, or a hit. Now, you can't actually see a force, but you can absolutely see and feel what it does all around you all the time. It's the effort you use to pull open a door or the impact when a bat hits a baseball.
So, what happens when you apply a force? What can it actually do? Well, it can do a few really important things. It can speed an object up or slow it down. It can totally change the direction an object is heading. And sometimes it can even change an object's shape. You know, like when you squeeze a lump of clay.
Okay, but here's where things get a little tricky, a little more interesting. What about those times when you push on something? I mean, you push with all your might, and it doesn't move at all. How does that work? Well, this introduces a new idea. Not all forces are created equal.
And the solution to this puzzle comes down to two big ideas. First, you've got balanced forces. Think of it like a game of tug-of-war, where both sides are pulling with the exact same strength. What happens? Nothing. The rope doesn't budge. The forces cancel each other out. But then you've got unbalanced forces. This is when one team in that tug-of-war pulls harder than the other. An unbalanced force is what actually causes a change in motion. It's the game changer.
Let's make this real. Picture this. You're trying to push a super heavy box across the floor. You give it a little push, but the force of friction between the box and the floor pushes back with the exact same strength. The forces are balanced. The box just sits there. So you push a bit harder. Guess what? Friction pushes back harder too. Still balanced, still no movement. But then you give it one massive shove. Your push is finally stronger than the friction. The forces are now unbalanced, and bam, the box finally starts to move. And that idea, that it's the unbalanced forces that really matter, was the key. It was the breakthrough that let thinkers like Galileo and, of course, the one and only Isaac Newton completely revolutionize how we think about motion.
It really started with Galileo and this just brilliant thought experiment he came up with. He pictured a marble rolling down a ramp. Obviously, it speeds up. Then it rolls up another ramp and it slows down, right? It's trying to get back to the height it started from. But then Galileo thought, what if the second ramp wasn't a ramp at all? What if it was just perfectly flat? In a perfect world with no friction, that marble would just keep rolling forever, trying to reach a height that it could never get to. This was huge. It meant that things in motion don't naturally want to stop.
And this is where Newton comes in. He took Galileo's amazing idea and he just nailed it down with this powerful, elegant statement, his first law of motion. Basically, it means things like to keep doing whatever they're already doing. If something's sitting still, it's going to stay still. If it's moving, it's going to keep moving at the same speed in a straight line. The only thing that can possibly change that is an unbalanced force.
And this stubbornness, this tendency for things to just keep on doing what they're doing, well, it's got a name, inertia. Every single object has it. It's the reason things don't just randomly start or stop moving on their own.
Now, inertia might sound like some fancy physics term, but trust me, you feel this thing all day, every day. So let's talk about how this big idea shows up in your world.
So that brings up a pretty important question, right? If every object has inertia, does that mean a tiny feather has the same inertia as a massive bowling ball? Or does an empty cardboard box have the same inertia as that same box filled with bricks?
I think you already know the answer. Of course not. It's way easier to give an empty box a shove than one that's full of heavy books. It's a lot easier to kick a football than it is to kick a stone that's the same size. Why? Because the empty box and the football have less inertia. They put up less of a fight against being moved.
And this right here is the absolute key takeaway. The mass of an object is how we measure its inertia. It's a direct link. The more mass something has, like a freight train, the more inertia it has. The less mass it has, like a bicycle, the less inertia it has. More mass just means more resistance to changing its motion. Simple as that.
Okay, so this is where it all comes together. You have totally felt this. Think about riding in a car. The driver suddenly slams on the brakes. The car stops, but your body, because of its inertia, wants to keep moving forward. That's why you lurch forward against your seatbelt. And the same thing happens when a bus takes off really fast. The bus moves, but your body tries to stay put, so you feel like you're being thrown backwards. That's Newton's first law, live and in person.
So there you have it. We've cracked the case. An object in motion doesn't need a constant push to keep it going. What it needs is an unbalanced force to change its motion. Rest isn't the default state of the universe, just continuing on is. So my final question to you is, now that you know this, as you go about the rest of your day, where else are you going to spot the law of inertia at work?